Hello and welcome back to SAS From Scratch. Today's episode is episode 15. This corresponds to chapter 15 in the official prep guide as well. And we're going to take another look at the PROC FREQ and PROC MEANS procedures. Now we've already done so in chapter 7. Chapter 7 focuses mainly on the PDV, but in that chapter of the prep guide, they also use PROC MEANS and PROC FREQ to check for a few basic data issues. So episode 7 does the same thing, but there are a couple of extra things that we need to be aware of for the SAS base exam when we talk about PROC FREQ and PROC MEANS, and that's what this episode is going to cover. So, something quick to note. There are some keywords and options that I skipped for the purposes of this video. To keep the video on track, to keep it focused on the core ideas of what you need to know, but you will have to go through chapter 15 in the official prep guide for a couple more details before writing the exam. What we're going to cover here today is going to cover basically, let's say 95% of what you'll actually need to know for the exam, but it's always good to be aware of all of the keywords and options that are available when dealing with the different procs. Now let's start with PROC MEANS once again, and let's remind ourselves PROC MEANS is a procedure which provides data summarization tools to compute descriptive statistics. Ignore the hyphen in between descript and tiv. Descriptive statistics for variables across all observations and within groups of observations. So you can see the syntax in the box below, and it's pretty much what we expect from a SAS proc. So we have our name, which is PROC MEANS. We have the data parameter, data equals, and then whatever SAS data set we're plugging in. The statistics keywords we're not going to worry about too much for the moment. There's, I think, stuff like confidence intervals and whatnot that you can plug in there. But we're not worried about that today. We then have the by variables. We already know what by groups are. We've covered them extensively in, I believe, episode 8. The vars. The var statement is all of the variables that we are doing statistics on. And the class variable is equivalent to the by variable, but there are some small differences to be aware of. Then something we didn't cover before is the output statement, which is extremely important, because that's one way of getting whatever your stats are, instead of just spitting it out onto a results tab, to get that into a data set and use that data set as input once again for a different data step or a proc or something else. And we're not going to go in depth on all of the different functions that are available when we use PROC MEANS, but we will go into basic descriptive statistics, so we can look at, for example, counting things with n, averages with mean. We can do median, standard deviation, minimum, maximum, that sort of thing. And that's the gist of what you need to know for the SAS base exam as well. So moving on from the syntax we just saw, the by statement specifies our category variables, so that's whatever our by group's going to be. Var is the numeric variables from which we are going to calculate statistics. Class is category variables for group processing. You'll notice that by and class say the same thing, but there's a small difference between them. And the output statement is something we've not seen before when dealing with PROC MEANS, and that's just a way of writing the summary statistics to a new data set. Now, by and class differ in the following two ways. By needs the data set to be sorted in advance. Class does not. And when we look at the results table in the result tab, by will create a table for each variable. So you'll have them be almost paged by that. It'll be separate tables depending on each by group. Whereas class will continue to do the grouping, but it will put everything in one large table, basically. And we can look at an example of that as well, but for now, just be aware that that's going to be the two main differences. I'm going to illustrate all of these principles in the exercise. So I'm not going to do a bunch of examples in between because we've already seen the basics of PROC MEANS and PROC FREQ. PROC FREQ we've talked about as well. It creates one-way, two-way, and n-way. Apparently n is anywhere between 1 and 50, so that's your limit, up to 50-way frequency tables. And it describes data by reporting as well the distribution of variable values. So it's a fancy way of counting, essentially. If we look at the syntax, I'm going to go one slide up again. So this table's procedure, you can either put a number of variables separated by spaces if you want to count to generate the frequency tables for each variable on its own independently, or you can have variables versus one another or by one another. So if you want a two-way or a three-way or whatever table, you would group them with these asterisks, basically. So you could do something like sex by age or something like that. So you can either do the first statement or the second statement. So tables specifies the variables to be processed by the FREQ procedure. Straightforward, we've seen it before. And then you are supposed to be aware of all of these options as well. Know them by heart. So no cumulative suppresses all of the cumulative frequencies. List gives you the output for the cross tabulations in list format. Cross list for the cross tabulations in ODS column format. No frequency suppresses cell frequency, so that's if you don't want the actual counts in the cells. No percent suppresses the percentages, so by default you'll have something like, let's say you're doing a table on sex, so you'll have female and you'll have male. It'll say, okay, well, there's 10 males and 10 females and 50% to each of them, and it'll show 10 and 50% in the cell every time. And then what PROC FREQ will also do by default, and we saw this in episode 7, it'll generate column rows and percentages, and it'll do column frequencies and percentages, and it'll do row frequencies and percentages as well. And so you can suppress that as well with the no row and no col options. Now you're not going to add a slash for every single one of these. If you want to add options, you're going to add a single slash and you're going to type all your options separated by spaces. And we'll look at an example of that in the exercise as well. So I don't want to spend too long on this. I think I've said most of what needs to be said for PROC MEANS and PROC FREQ in episode 7. And this is just a little bit extra information that you need to be aware of before you actually go and write the exam. So we can move forward to exercise 15.1, and there's 2 exercises in this episode today. So there's going to be a 15.1 and there's going to be a 15.2. 15.1 on PROC MEANS, this is the longer one. 15.2 on PROC FREQ, very short, because there's only so much you can do with something that's supposed to count anyway. So let's move on to exercise 15.1. And as you can see, we're using the sashelp.fish data set again. I have already prepped a program for us, and it's got all of these instructions in there again, but we've got probably one of our larger exercises out of all the episodes here. and we're going to spend some time on that instead of spending time on the slides. So we're looking at getting, because the SAS help.fish dataset has a length 1, a length 2, and a length 3 column, we're going to combine that into one column. We're just going to call it length 0. And that's going to be the average of these 3 variables per row in a row-wise fashion. We're then going to drop length 1, length 2, and length 3. We're going to get the average weight, length, height, and width. Now length is going to be now the length 0 column. And we're going to do that for each species. So now instead of doing something row-wise, we're going to do it in a column with a by group. We're going to take these results for the averages. We're going to put them in a data set called average, AVG. And we're going to merge that data set, that resulting data set, back onto the individual fish data set, which will allow us to figure out which fish are heavier and which are lighter than the average for their species. So let's get on to that. Ignore this. This is episode 16, and we're not supposed to look at episode 16 yet, but I prepared these 2 at a time, so you can get a preview of what episode 16 is about. Exercise 15.2, I'm going to move down as well because we're not too concerned about that at the moment. So let's start with this. We know we're going to use the SAS help.fish dataset, so let's just bring that in already. And because we're busy coding, I should move my face. I will sit here in this corner. Now, our first instruction is, in a row-wise fashion, get the average of length 1, length 2, and length 3. Let's remind ourselves what this data set looks like. So we have, I'll move this in a bit, we have length 1, length 2, and length 3, and for each row we want to get the average, and we want to place that into length 0. That's pretty straightforward, because we know that if we want to do something row-wise, we do it within a data step, because that's the way the PDV works. So we can say length 0 is the mean of length 1, length 2, and length 3. If we run this, we get length 0, which is the average of the previous values. Well, these 3 values, and this is done in a row-based fashion. So for each row, there's a unique average length, or pretty unique for the most part. We are then instructed, after placing the average into a column called length 0, to discard the length 1, 2, and 3 columns. We already know how to do that. That's a simple drop statement. We can, sorry, no commas here. I've been spending too much time in R. We can run this. And we now have species, weight, height, width, and length 0. So we've gotten rid of the extra information. Now, we would like to get the average weight, length, height, and width for each species. We're definitely going to have to use a PROC MEANS for that. So PROC MEANS, our input data will be the fish data set. We always close with a run. And we know that we have to do this by a certain fish species. Now, if we are using a by group, we have to also sort by whatever we're grouping by. We can also try and do it with a class, which will require us to not sort it. So let's start with a by, and then we'll at least see that we get an error because the dataset is not sorted properly by default. We are going to do by species, our variables are weight, length, height, and width, but we have called it length 0, and then we've got weight, height, and width. So, and we want to output the results to a dataset called AVG. Now, this is the bit that is new that we have not covered before in episode 7. You need an output statement to accomplish this. And within the output statement, you need to provide the name of an output dataset to SAS. So in this case, we're going to call it output is AVG. Now, if we run this, we will get an error because our dataset's not sorted. You can see it's complaining about sorting in ascending sequence or not. If we switch this over to a class statement, then we get this. So we've got this which is not sorted properly, but it does not matter to the class statement. And if we look at our output data set, we have our stats. So in this case, the way that it has been output is to have the stat in a column. We're going to look at a different way where we have it across in one column across different rows. We're going to look at a way of having it in one row across different columns. So this is basically the empty species, and what this is this is across all species. So it's telling us there were 159 different fish. There were n variables taken into account here. For length, for weight, only 158, because if you go and look in the data, the one fish actually has a missing weight. We can see that there's a minimum, a maximum, a mean, a standard deviation for length. If you also look here, you can see that there's a minimum of 0 for weight, which does not make sense in the big scheme of things. So this is actually pointing to some data issues. And so the class statement will give you this by default, and the by statement will not. So the class statement will give you this sort of overall view, and the by statement will not do that. The by statement will immediately go into the different groups, or all the species we've got here, basically. Okay, moving on. What we do want to look at, however, is to get, say, the names in a way that we would like to display them. And the way we would do that is to specify a name for all of these different variables that we are inputting into the PROC MEANS procedure. And in whatever output we are asking from the PROC MEANS procedure, we would put that in a name. Now, it's important that the name we provide, say, for example, for the column where the mean has to be placed into, that order corresponds to the order in which the variables are listed here. So it would have to be, for example, let's call it, and I'm using underscore average on purpose here because I want to demonstrate something in a bit. Okay, so we've got an output statement. We're telling SAS that the output has to go to a dataset called average, AVG, and this will go to the work library by default, of course. And then we are also specifying the names of columns that the mean values for these variables have to be placed into. So the mean for length 0 is going into length 0 average, but I could have called this anything and it will put it in there. It is not related to the fact that this is called length 0. Weight goes into weight average, height into height average, and width into width average. Now, I don't like the way this is written. I prefer having something more readable, and the way you can neaten that up is with a bit of spacing and indentation as well. So this looks a lot better and is a lot more readable. Now if we run this and we go and look at our output data, you'll now notice we've got length 0 average, weight average, height average, and width average, and we've got it for each one of these species. What we've also got is the overall grouping still. Now if I switch this to a by statement, and we will have to sort our data as well. If I don't specify an output data set, for example this, or fish2, or whatever it might be, SAS will just overwrite this data set that it's reading in. So it's reading in this fish data set, and it sorts it and overwrites it. Now, do as I say, not as I do. Don't do this when you're working on actual projects in real life. Use the unsorted one and give it a particular name, and then for the sorted one, give it a particular name. It's not considered good practice to overwrite the data sets like this. So let's run this. Note that we now have a by statement. And note as well, you can go back in the video and you can rewind, but you'll note that before these were all in one big table, whereas now each species has its own little table here in the results tab. If we look at the output data in the average data set, we have we don't have that blank species, which is the overall statistics. We have our individual species, we have length 0 average, weight average, height average, and width average. Now, something that I do want to illustrate, what you can do is you don't have to specify the names for each and every single item that you've got here. So you can do, for example, mean equals, min equals, max equals, and then you can simply specify an option like that. And keep in mind that if you wanted to write it in one line, you would do something like the following. I'm just trying to tidy this up. And this is actually feasible to write in a single line. Now, auto name will tell SAS to name these variables for you. So it'll call it, for example, underscore mean, underscore min, underscore max, but you don't have to go through the schlep of doing that by hand manually. So there you've got length underscore mean. If we keep moving on, we have underscore min, and we should have underscore max as well. We can add extra statistics. We can say, for example, median equals and standard deviation equals. And if we add that, it'll just keep adding all these statistics that we asked for. So you can see we've got our standard dev, we've got where's median? There's median. So we can ask for all these columns and we can use them. However, in the case of this exercise, we were asked only for the average weight, length, height, and width, and we are going to output the results to a dataset called AVG. We've done that. I'm not going to worry too much about taking out all these extra statistics, and I'll show you why, because we're just going to, well, I'll tell you, we're just going to drop them as soon as we merge them in. Now, the last item within this exercise asks, using the average results, compare the weight of each individual fish with the average weight for its species. And then we're going to make a finding column, and we're going to determine is a particular fish lighter or heavier than the average for its species. Now, within this AVG dataset, we have condensed everything by species. The useful thing is this is sorted and grouped by, and our original fish dataset is also sorted and grouped by species. which means we can merge them quite easily. We can bring these statistics in and we can do a comparison. Now, that is something that is not as nice to do maybe as you would with R. So if we look, for example, at a bit of R code, if we say, you know, fish2 takes in fish, we can group by species, we ungroup because that is good practice, and we do something like mutate, what did we say was this? So let's say it's weight mean equals, is the function avg or is it actually mean in R? Let's assume it's mean weight. So within R, you could do something like this. And if you don't use the summarise function, it won't condense that data by the group. So you could still group by it, you could mutate it, and you could keep all of the data, but you would still get the mean weight on each row grouped by species. Now that is not something that is too easily accomplished by the default SAS functions. You definitely cannot do it in a data step because of the way that the PDV works. You will have to use a PROC MEANS for it. Your alternative is to use PROC SQL, which honestly would have been my preference in this case, but we are not at the moment dealing with PROC SQL because it is outside the scope of the SAS base exam. So if we go to SAS Advanced, maybe in a future series, if I can get the energy for it, we will look at this example again with PROC SQL. But in this case, to do basically the same thing, we need to do all of these steps and we need to bring that into the original data set with a merge. So let's do that. So we can say data, let's call it fish2. And if you don't know how to merge data in SAS, we did so in, I believe it was episode 10. It's the one that's titled The One with the Set and Merge, because I am apparently an aspiring series producer. Merge fish and merge average. Now this is going to give us a big data set with a bunch of extra columns that we don't need. What do we definitely know that we are going to need for this exercise? We know that we need to keep the species column because we have to merge on it. And we know we have to keep the weight mean column because we're comparing whatever weight we have with the average weight for that species. Now we're merging by species. That's why we're putting it in there. And if we run this, it will give us, these are all of our original columns, and then there's weight mean. And why does something look off here? No, probably fine. Probably fine. Whatever. If there's a mistake, you can let me know down in the comments below. That's the wonderful thing about the internet. If you get it wrong, you'll have a million people in 5 seconds telling you got it wrong. So we want to create a finding column. That was our original last instruction here, which says using the average results, compare the weight of each individual fish with the average weight for its species, create a column called finding, and then specify whether each fish is lighter or heavier than the average weight. So that's a fairly simple instruction. If the weight is less than weight mean, then our finding is that this fish is lighter. Else, if the weight is greater than weight mean, then our finding is that this fish is heavier than the average. Else, if it's not lighter, it's not heavier, must be equal. The chances of that happening are extremely slim because of decimal places, but you never know if that will happen. So I will even put in a couple of exclamation marks so we can easily spot it. If we were clever, we would even just use a put log statement and we would write it out in red letters to the log. So this one, weight 242, you know what, let me make my life even easier. Let's keep only species and weight for the input data set as well. So if we do this and we run it again, we get a weight of 242 is lighter than 626, that makes sense, and 700 is heavier, 610 lighter, heavier, etc. And you can see that when we move from Bream, our mean weight changes from 626 to 154.81. Now we could have rounded this and it would have been a bit neater, but we're not going to worry about that now. If you need to know how to round, previous episode, I believe it was 14C, covers numeric functions and how you do rounding in SAS, which again is a little bit different from how you would do it in R. So we have lighter and heavier for all of these, I think. So there's a fish with a missing weight, and this is important to keep in mind as SAS says that missing is always less than something that's quantifiable, which makes sense. The other item, there was a fish with a weight of 0 somewhere. I don't spot it now, but I know it was in here because we saw it in the stats as well. Moving on to the next page, we have heavier. The perch average is 382. I'm specifically looking to see if anything is equal, but it is not. So there's the weight of 0 for this roach. That cannot be correct. So some of these, you know, there's a missing value or there's a value that doesn't make sense. The whole point of these example data sets is sometimes to introduce some data issues. That is basically everything this exercise asked us to do. And why I like this exercise, and I really am patting myself on the back here because I'm setting up these exercises, so forgive the narcissism. Why I like this exercise is because it tests a few things. So it tests reading in data. That's what we did here. It tests row-wise descriptive stats functions, like for example mean. And it also teaches us how to drop or keep certain things in different ways. So that's a drop statement, that's a keep option. And so that statement versus option thing is also something we've covered in a previous episode, and you must know it for the SAS base exam. It covers sorting, it covers our PROC MEANS, and it even includes this handy dandy nifty auto-name functionality which SAS provides. We then merge that statistics, those descriptive statistics, back onto our original data set, and we implement some conditional logic. So if anything that I've done here in this exercise does not make sense, you do need to go back and watch the previous videos again before you even think of writing the SAS base exam. You should be able to do this from start to finish, no issue, as an absolute minimum for the SAS base exam. Why do I say minimum? Because we've not even touched do loops. We've not even touched retain statements to, you know, manipulate the PDV. So this is an absolute minimum understanding that you should be able to do almost blindfolded before you think of going to write the SAS base exam. Okay, strict teacher mode aside, let's move on to exercise 15.2 and let's read it in the context of the slides. Let me move my face back up. I'll sit there. 15.2, we're going to use the SAS help.cars dataset. We're going to create a two-way frequency table of the cylinder versus drivetrain columns. So how many cylinders does a car have? Is it 3, 4, 6, 8, maybe even more? Maybe there's a 10 cylinder or 12 cylinder, who knows? And then the drivetrain. Is it front wheel drive? Is it rear wheel drive? Is it all wheel drive? So 4x4, for example, that's all wheel drive. Your sports cars, your fancy ones, they're normally rear wheel drive, and your normal day-to-day standard city living cars, they are going to be front wheel drive. So we're just going to create a simple two-way frequency table of the cylinders versus drivetrain columns, and we're going to output these frequencies to a dataset called FREQ. Now, this is something, when we talk about output for PROC FREQ, that's something that we need to be careful of, because there's one way of outputting the frequencies and there's another way of outputting different statistics. So I'm not going to go into both because it's outside of the scope of the exam to my knowledge. Go through chapter 15 and just make sure I'm not talking nonsense here. But we're going to do the very, very simple one where we simply output frequencies to a table, because that's also what you're going to find most useful in your day-to-day use of SAS. Additionally, to keep the results tab simple, so something's going to the results tab and something's going into an output dataset. Now it's going to be the same values, but they're displayed a little bit differently. To keep that results tab view simple, we're only going to keep the individual cell frequencies. What do we mean by that? By default, and we'll look at that in the example, SAS is going to want to give us cumulative frequencies, individual percentages in each cell. It's going to try and add up the rows and columns and give us percentages and frequencies for that as well. So that's what we're trying to stop. We'll look at that in the code itself. So let's go back to SAS Studio. Let me move my face back down here, or even up there, if we want to really switch things up. Moving on. So what do we know? We're definitely going to need the SAS help.cars dataset, but we don't need to manipulate anything about it, so we can read it in directly. Now, we are asked for a two-way frequency table of cylinders versus drivetrain. So if I do this, what I'm going to get is one table for cylinders and one table for drivetrain. Let's do that. This is our FREQ procedure. There's cylinders, there's drivetrain. This is two one-way frequency tables. I want one two-way frequency table. And you'll notice here that we have what is the frequency, what is the percentage, etc., etc. What is the cumulative frequency percentage, which basically counts down and it adds up to 100% and the full count at the end. Let's fix this so that we actually have a two-way frequency table, and we do so with the asterisk to indicate cylinders by drivetrain. I went over this in a little bit more detail, maybe, or at least, a bit more elaborately in episode 7. We run this, we get cylinders down here, we get drivetrain across here. And these are all of the extra bits I was talking about. This is hard to read. So we have frequency in our top row, so that's 0, 1, 0, 1. And this total column is of course here, and this total row is in here as well. Percentage 0.23% for a front wheel car with 3 cylinders. Out of the total of 426 cars, 1 over 426 should give you 0.23%. That makes sense as well if you quickly do that number in your head. This is the row percentage, this is the column percentage. This makes this table very hard to read. What I want to do is, while this table looks like this, and it'll also warn you that there's missing, so there's a particular option you can look in the base prep guide to suppress this information. What I want to do is show you how to get the output of this, because we only have log and results. We don't have an output tab because it's not been placed into an output dataset. So let's output it to a dataset called SAS FREQ. And if we do this, we need to add the slash here for the options, and we need to specify an out dataset as part of the option. Now, this is what our results tab looks like. This is what our output table looks like. So you'll notice that we have some missing cylinders, and we know there's 2 of them. We know there's one front wheel drive car with 3 cylinders. There it is, percentage 0.23. So note that here in this table, we simply have count and percent. And we do not have all these results that we see in here. So what we see in the results and what we're going to get in that output tab are different. That still counts even if in here we suppress the cumulative rows and columns, the percentages, the etc, etc. The row and column percentages as well. So once we suppress all of that, our output should still look like this. It should still have both the count and the percent, even if we suppress percentages in here. Now remember I said that this slash for options you're only going to put once, and then you're going to specify all your options. So for example, to suppress all of these things, cumulative frequencies, individual cell percentages, and row and column percentages, we're just going to type the options separated by spaces. So we're going to do no cumulative, no percent, no row, no columns. And if we run this, note that our frequency table in the results tab is now a lot simpler. We only have counts, and it's much easier to read. If we look at our output table, it still looks the same. It's still got the percentage and the count column. So if you really didn't want this percentage column, you could simply drop it. You could probably even do something like this, and it should work, I think. I don't use PROC FREQ all that much. Correct. Yeah. So that's one way of dropping it from the output. Now there is a way, and again, as I've said, I don't use PROC FREQ. I almost never use PROC FREQ because I dislike this procedure. But there is a way to get the statistics output as well, and it is to do with an output statement, but you would have to go and check the SAS help online or your SAS prep guide if it's in there. I don't even think it's in there because it's not, to my knowledge, in the scope of the SAS base exam. But there is a way of getting some of these statistics, the percentages and row and column percentages and all that sort of stuff out of the results table and into a output table, a data set. Well, that is basically it for exercise 15.2. We've done 15.1, we've done 15.2, we've wrapped up the exercises, and with that we've basically wrapped up the episode as well. This is a very, very good test to make sure that you know what you're doing for the SAS base exam. you need to be able to do this, like I said, blindfolded. Every step of this should come very naturally and automatically to you. Moving on from the exercises, next time, let's talk about what we're going to do next time. There's a system which SAS has called the ODS system. That's redundant because ODS stands for Output Delivery System. And ODS is a way of outputting, for example, the results that we see in the results tab when we use a PROC FREQ or a PROC MEANS or a PROC print. It's a way of taking that output and placing it into a different format, like HTML, PDF, RTF, or Excel. These are there might be more, but these are the 4 that are covered in the SAS-based prep guide. If you are familiar with R and you're coming from R, something to compare it to would probably be your R Markdown stuff, but it's not, at least for me personally, it's a much more older, rigid system than R Markdown. But it's one way of thinking about it. So R Markdown is a markdown language. So if you've ever worked with LaTeX, or even if you've worked with something like PHP or ASP.NET, where you have some static content and then some live content that's being generated by the underlying programming language. Whereas ODS is essentially just take whatever I'm printing here and put it into something else at the same time. It's comparable, but it's not really close in terms of functionality and ease of use. But it's one way of quickly getting, a table with some results to, for example, your boss who just wants to see a couple of numbers in a PDF file. It's not something that would be used really for, I say that, I need to be clear on this. So ODS is used for professional reports, but it's simply a wrapper around procedures. So you would wrap something, for example, in ODS PDF tags, and whatever happens inside that goes to a PDF document. That's all fine and dandy. However, you do need to use a lot of effort, for example, with a PROC report procedure, to make sure that whatever you're putting in this PDF looks nice and is presentable. It's not quite as easy to have nice looking documents with ODS as it is, at least for me, with R Markdown. That's for next time. That's episode 16. We've only got 16 and 17 left, and then I will do an episode 18 as well, which will cover some exam stuff, at least some exam tips and whatever I can still remember from the exam. Some thoughts on the exam environment, and some general tips and tricks for the exam. Okay, that is it for episode 15. Go and practice the exercises on your own. Make sure you read through the chapter, because I did leave out some keywords. But until next time, thank you very much for watching. I appreciate you sticking with me through my waffling and rambling. Feel free to leave a comment if you have anything to add to the discussion. If I got something wrong, you can leave a like if you enjoyed it. You can subscribe if you want to see the next episodes in your subscription list. Other than that, that's everything I had to say for this particular episode. Thanks. Cheers. Have a good day. Bye-bye.